So welcome everybody. It's great to see so many people again that join us for just before the weekend. And as you can see, I'm not Andy. So my name is Julia and I'll be hosting today's session. So after last week's brown bag with Tom Falkenberry on Bayesian analyses, I'm happy to welcome you to our second pre-conference MCLS brown bag on open science with Krzysztof and Mojtaba. And before starting with the presentation, let me just quickly make some announcements, which some or most of you might have already seen in their mailbox. So first, this is the really final reminder for those of you who submitted to the MCLS 2020 conference and would like to participate in the virtual online version. So please respond to the conference form by today, so it's only a few hours. We will be sending around a schedule inquiry once all responses are in, and the upcoming presentations will take place weekly, so as we have it right now, and they will alternate between Thursdays and Fridays. So Thursday a bit early in the morning, Eastern time, at 9 a.m., which is 2 p.m. British summer time, and then Friday same time as we're now used to. And we recognize that sort of this scheduling will not work for everyone, and we hope to schedule some special sessions for our friends on the other side of the world. And of course, all sessions will be recorded and posted to the MCLS YouTube channel. Second, please join us next Friday. That's going to be a nice thing for our official virtual conference launch party. So that will be the same time as today. So come with your coffee or tea, or maybe also beer, wine, champagne, whatever you feel like, to celebrate the launch of our virtual conference, which will be ongoing for a couple of months because we already received quite a lot of people, like huge interest in participating in this online version. And finally, a quick reminder to all MCLS trainees to not forget to take part in the MCLS trainee board election. The deadline is next Friday, so another week. So now getting to today's plans. The session will be recorded as usually and uploaded to the MCLS trainee YouTube channel in the next few days or so. So if you do not want to be recorded, please turn off your camera now. The presentation of Mojtaba and Krzysztof will last about 30 to 40 minutes, and I reminded them of this, so let's see how this is going. So ideally, we will have plenty of time for questions and comments afterwards. If you have questions, please write them in the chat, and Krzysztof and Mojtaba will address them after the presentation, unless it's clarification questions, then please speak up and ask directly. In case there is more questions, so you can't squeeze it in this 1 hour, Mojtaba and Krzysztof kindly offered to stay a bit longer to make sure that all the questions will be answered. So a few words on today's speakers. Mojtaba did his master's in occupational therapy in Tehran in Iran, and then moved on to University of Tübingen in Germany, where he received his PhD for his work on neural behavioral correlates of arithmetic development and learning in children. And just recently, so at the beginning of this year, he moved on to work as a postdoc at the Brain and Mind Institute of Western University in London, Ontario, Canada. Krzysztof, on the other hand, studied psychology and also did his PhD at, I have no idea how to pronounce that university, Krzysztof, I'm sorry.
Jagiellonian University.
Thank you. In Krakow in Poland. He then moved on to Tübingen in Germany as well for a postdoc where he continued his work on spatial numerical associations. And in my mind, Krzysztof is one of the most enthusiastic SNARK people there are in numerical cognition, I would say. So, but he also works on other things, such as math anxiety, for example. In April this year, he joined the Center for Mathematical Cognition at Loughborough University. So as you might have realized, the two spent some years together in Tübingen, and I think, I don't know, roughly 2 or 3 years ago, they got quite enthusiastic about open science, and that's at least one reason why they're here today, I think. So I will hand on to Mojtaba and Krzysztof. I'm looking forward to your talk.
Thank you very much for the nice introduction. I'm very pleased to be here discussing open science today. Today we split the presentation to two parts. The first part will be given by me. I will talk about the problem, where is the problem basically, and then how open science will address that, and then two important parts of open science as pre-registration and register report. And then I will hand it over to Krzysztof for the more interesting part. He will talk about how to share materials, data, analysis code, about preprint, open access option in journals, open peer review possibility, reproducibility, replication, and then he will end up with the benefits for us as trainees. Okay, let's start with the research cycle. The way that usually we do science is we specify our hypothesis, and then we design our study to test those hypotheses, and then we go to collect data, we analyze them, and then we interpret and we publish them. But there are several questionable practices in this circle. For example, there are studies that you see all have been cited. There are studies showing that there is only one in 1,000 paper, which is a replication paper. Why it's important? Because we have studies showing that, for example, in psychology, there is only 1/3 of the studies are replicable, basically. So this is a big problem, because we are building our theories, models, and conclusions and transfer it to public based on these findings. But if 2/3 of the findings are not replicable, it means that probably, in simple words, they might be just noise. It's not a real finding, maybe. Most of the studies suffer from low statistical power. We go to this point later. But I think this is also very clear. Many of us did, and still we do, p-hacking. We do many tests, and we just report the ones that we get significant result there. We do also harking. Harking is the abbreviation of hypothesize after the result is known. We conduct a study, we get the result, and we find in just one part of the findings very interesting result. So we say that, okay, this is what I thought from the beginning. So we write our paper based on that, which is sort of lie. And we have publication bias. This bias is forced sometimes to us by the journals. They don't accept null findings, for example, or something which is not on the mainstream. If everybody found A, if you say, no, A is not true, you know, they are not so interested in, because they might get in trouble. So that wasn't practical. So in simple word, what would be then the problem if we do hacking, harking, all these things? Or we don't do open science, or we don't share the things. The first point is that we need to reinvent the wheel. For example, you made an MBAC task, which is quite nice, you publish it, and then I'm going to do in my study, I need the MBAC task. I have to make it from scratch because it's not available. This is just a simple example. We have replication crisis that I mentioned before. We are slowing down the whole procedure of the science, because we are building everything from scratch for our own. But if I could get all the materials, for example, or analysis code, all these things, I can just put them, integrate them to mine, which is way faster. We have limited access to the output, because most of the time we give the copyright to the journals and people have to pay for that. We have publication bias, as I mentioned, and we are skipping our copyright. This is an interesting issue that Krzysztof will address later. Here is just an example. We talked about this. 90% of the studies in psychology confirm the hypothesis. We know that in the lab it's not true. Is it really true that 90% of the time we find whatever we thought at the beginning? At least my experience says no. And here is another example of clinical trials. In 2000, they defined a pre-registration of the board. And beforehand, you see, based on the majority of the findings, which are low power findings, most of them they say, well, these trophies, they have positive influences on the performance. And a few of them says no, it doesn't have influence. But after pre-registration, you see the pattern changes totally. Only two low power here, they said it's influential. And most of them, they said, no, it's not influential. And even one reported negative influence. It's actually hurting. We think that open science will be a solution, good solution for those problems and issues. In simple word, open science is to make science, all this journey, accessible to everyone. It has several advantages. It enhances our research quality. We will be transparent and honest in science. Data, if we share it, for example, are reusable. We get the chance of more collaboration with people. We get more citations. For example, if we don't do open science, we might get cited only by our final output. But if I'm sharing everything, I might be cited for my NBAG task that I shared, for example, for my analysis code, and all the way to the final one. Public can have access to that, and we are speeding up science. Basically, this is an important thing for us. As you see here, open science taxonomy is a very broad and broad field or definitions. But today we will stick to more, let's say, superficial or more general definition. We don't go so much to the details that you see on the right side because of the lack of time, obviously. Okay, coming back to the research cycle, we see that open science will address many of these issues that we discussed so far, that we go one by one to each of those. Let's start with pre-registration and register report. To start with that, maybe we step back and look at the study design. We have a sort of continuum, which we call ADGOOD continuum, which goes from exploratory studies to confirmatory. Exploratory is something that we generate the hypothesis later. It's more data dependent. So we get the data, and then based on the analysis, we give the message. Usually we do many analysis here, and we report only significant ones. It has many other problems that I didn't list here. On the other side of the continuum is the confirmatory way of doing science. We hypothesize before we start data collection, and we test our hypothesis. Our hypothesis is data independent. We don't make it based on our finding. We have it, and we just go to test it. The way to do that is register report, registration, and power calculation sample size. And there is another interesting part, which is in the middle, which we call gray zone. It's neither exploratory nor confirmatory. For example, what we do is we measure multiple variables. We add hundreds of covariates into the model. Or we do a design, we have a design, for example, of 2 by 2 by 2 by 2 ANOVA. And then we just find one effect in the postdoc, and we try to justify that postdoc. You see, it's not fully exploratory, but it's not also confirmatory. And we adjust data transformation. We do the analysis under row RT. We see nothing. We transform it, for example, to log RT. We find something. We say, here we go. I report the log RT, of course. What's okay and what's not okay? If we run an exploratory study and present it as an exploratory, that's totally fine. If we do a confirmatory and report it as confirmatory, it's fine. But if we run an exploratory study but present it as confirmatory, it's not okay. Here is very nice cartoon. You see, this is exploratory. This is, I'm shooting and then I'm making the target around that. And on the other side is confirmatory, obviously. And this is very lovely. This is what we do most of the time, unfortunately. We torture our data to get something out of that, to report it. I hope you agree that most of us did that, and we are still doing that. Okay, let's jump into pre-registration. What's pre-registration? Pre-registration is submission of our idea in relevant websites. It will not be peer-reviewed, and you can store it as private or public. You will receive a stamp on that with DOI and date of submission, and you can later submit it to the along with your paper later to journal, saying that, look, we hypothesize and we pre-registered it like 2 years ago. But anyway, it doesn't guarantee publication, but it increases transparency and trust. When can we do a pre-registration? We can do it before data collection, or when we submit the paper and the reviewer asks for further data collection, we can do it at that time. Or we collect the data, but we haven't looked at data. Here is a quote by Simons saying that we all do p-hacking. And being accused to p-hacker doesn't mean that we are a murderer, right? We shouldn't be defensive on that. We should really self-evaluate our work. We do it. I confess that I do, and I did it several times. But I'm practicing to stop that, to avoid doing that. Where can we pre-register? There are several websites that we can go and pre-register our work there. One of them is OSF, or Center for Open Science. That, as I said, you get a timestamp, it will be free there, and of course you need to provide sufficient information there. The other one that I like, I think Krzysztof agrees with me, is As Predicted, which is quite simple and straightforward to do. Here I put in a screenshot of that. There are 9 questions there. And based on my experience, if someone can really address all these 9 questions, he or she is doing a very good job, I would say. And you will have a very relaxed time later. If you start answering, if you can fulfill all these before starting your study. Because basically you are solving almost all the problems on that stage. The second, which addresses more officially the issues, is registered report. It's an official submission to a journal. It will be peer-reviewed by reviewers in the field, and again, we get DOI and stamp on the submission. This is the procedure that we do. We develop the idea and the design, and then we submit it to the journal. this is going back to our paper. It will be the introduction and the method part of our paper, basically. We submit it, it goes to the reviewer, you get comment on that, and you implement, you send it back. Hopefully you get an acceptance here on the stage 1 before you start data collection. And then you collect data and you follow exactly what you promised in the first stage. It has several benefits. Usually they are well-powered studies. It eliminates selective reporting, and it reduces the publication bias. If you find whatever, because the publication is regardless of the findings, basically. You get very good. I love this part because you actually will have 2 or 3 more experts in your study, which are not directly working on your project, but they're providing very valuable comments on your work. Basically, you can improve your work based on the expertise of many other experts in the field. And it reduces publication time, because for the stage 2, it's like it's guaranteed to be published. That's the procedure that I have already explained, more or less. As I said, you will submit these parts, its introduction method, and what's very critical and very important here is the sample size calculation and the analysis that you propose. You have to stick to that for your final report. However, if during the analysis of your data, you found something interesting, which is obviously exploratory, you can still report that, but with the subheader of exploratory analysis, you see that you are not so restricted. You have the freedom, but you have to be just transparent about that. So it's not about making more limitation. It's about increasing transparency. And then it goes to the editor, will be reviewed, either will be rejected, or you get in principle acceptance. And then you go to collect data, analyze it, and then submit it, and will be published. This is one very recent register report which came out this week, and we too are here. We are very happy of that publication. As you see, it has been a register replication report. With register report, you have different possibilities. One is like you have a novel idea, you are going and you have clear hypothesis, you go and register report that. The other is you are going to replicate one important or influential study. As you see here, we replicated this very influential study by Martin Fisher and his colleagues in Nature Neuroscience, which has been quoted hundreds of times. So it wants to replicate it. However, we failed to replicate it. And the other point is you will receive these badges. This is for being register report or to register, and these two are about 2 other things that Krzysztof will cover. If you are interested in knowing more about register report, there's very, very good cover by Open Science, by OSF. Actually, you can go and look at all these participating journals. I checked it today, it's already 244, including our the journal of our society, Journal of Numeric Cognition, which accepts registered report. Okay, I'm handing it over to Krzysztof to continue the discussion, the presentation about open science.
Okay, so now we go from specifying hypotheses into designing our study and then sharing materials. So, what are the problems with methods can we encounter? First of all, it's sometimes unclear when we read a paper which was published, what the authors have actually done, so in other words, the method section, it's not specific enough. Thus, like any form of replication becomes somehow problematic. We need to contact the authors and so on. And as Mojtaba already mentioned, several people need to actually reinvent the wheel. That is, like, if we imagine how many graduate students had to program a Stroop task themselves, probably enormous number of hours was just spent to try to replicate or reproduce some experimental task that someone like used and not even reported it properly about whatever, all the parameters or so. So what would be this open science, let's say, response to that? So it's of course the material sharing, which, as we mentioned, saves time and resources and gives also better control on the methods, because we can then actually just see what were the parameters or what were the items, what were the things that the participants were actually supposed to do during the experiment. Of course, then, except the, let's say, scrutiny and transparency, it's also just beneficial for, in the sense of like whatever, if you want to synthesize some research and so on, to really be sure who did what. And then what is very useful is actually using some open source software like CyclePy or Open Sesame for programming your experiments, because then everyone can just use it, and also the possibility to check it, to use it, is not dependent on whether you have the license, which costs a lot, or not. And then it's also good to share it with persistent link, for instance, to Open Science Framework, which I will mention soon. And here we have a screenshot of Open Sesame. So it's like the program for preparing behavioral and also physiological experiments. And then what else? We go further along our research cycle into data collection. And of course, there are several problems before open science about like lack of possibility for controlling the quality of the data. Someone might have to collect the same data again, because like no possibility or no access to the data prevented from doing some reanalysis, which could potentially serve as sort of pilot study or just set a ground for a new development. And many times while reading the paper, we see, okay, they were using these measures and probably this would be somehow related, but the data is not there. The authors did not analyze it. And if we really think it would be so useful, then we would have to really collect this data ourselves again. And what it also makes really big trouble is that like not sharing the data and only reporting some summary statistics causes very big difficulties in between study comparisons, and the constant problem of meta-analysis on how to unify, for instance, different effect sizes, which some of them come from ANOVA, some of them come from structural equation modeling, some of them from t-test, and so on and so forth. If the data is available, we have like much more possibilities of like synthesizing the body of research or body of results in the more systematic and quantitative way. So what can the open science offer us to solve this problem? So of course, data sharing, which allows optimal reuse of data, of course, taking the precautions that like we should really consider some safety measures, not to analyze the same data all over again, because there are also some claims that this data loses its value. You're just like capitalizing on chance related to this specific data sets. But as I say, it makes meta-analysis easier. And what we can and should do is actually using some dedicated repositories such as Open Science Framework, Dataverse, Figshare, which assign a specific DOI, specific digital object identifier, and a persistent link to our data set. So it's not that the website just disappears and our data also disappears. And also sharing the data would enable the quality control and checking for robustness of our conclusions and so on. But of course, it's also additional requirement for a researcher to make sure that the data is well documented. Because if we just share our data that we were said that we were working on, probably not to everyone it would be clear what each whatever codes, variable names, and so on mean. I will point you to some resources with some tips and guidelines on how to document your data before sharing. And then we go further. So problems with data analysis. We have no possibility to check for correctness, and of course, all the problems just sneak in into the report, and after the paper is published, without contacting the authors, we can only maybe detect some very obvious problems. And data processing and analysis description is also not sufficiently specific in several cases. Especially this was pointed in super prestigious journals like PNAS or Nature, where the method section is actually somehow suppressed and it's treated more or less as the supplementary material. And then reproducing all the procedures that were actually done from the raw data to the results that are presented and interpreted, giving very vital conclusions, is really, really hard to trace back. And also, if the data processing is somehow hidden, so to say, or not shared, then also people willing to somehow follow our method or apply it to some other research question would have to again reinvent the wheel, trying to somehow reproduce based on the value description how to program it and so on. So sharing code and analysis allows, first of all, quality control, everyone can check whether we put the minus sign in a proper place or not, and stuff like that. It also allows reuse of the analysis. And what is also quite important from the perspective of open science is actually that we use also freeware software which allows reproducible analysis. And here what is usually recommended is R, JASP, Jamovi, great software which allows all these things, and it's also free to use for everyone. And it allows really good documentation of all the operations that were made to the data. And of course here, another reminder, document and annotate your code and analysis. And then again, we go further in our research cycle, we publish the experiment. So the problems with publications, first of all, paywall is restricting an access to research products, which were actually funded from our public money, and the budget quite often determines the accessibility of knowledge. And this is also something we as scientists really would like to avoid, in my view. And then we encounter multiple copyright problems, and also the anonymized peer review is actually the only way of quality control. And maybe you have seen some discussions on Twitter about these controversial papers regarding COVID and so on, where the only response of the authors to people who were criticizing the paper was actually, this paper was peer reviewed, which probably was meant to somehow indicate that kind of whatever extraterrestrial power just came and approved it via peer review. But if you even count voices, people who raise concerns on Twitter, and there are 50 of them, and they are usually also quite familiar with the topic, and then the paper was peer reviewed by maybe, let's say, 2 people. Yeah, well, maybe this peer review in an official sense is also not the, let's say, the very, very final stage that we just believe without any doubt in the conclusion. So what can we do to make our outputs more open? So there are several ways of ensuring open access. One of them is green open access, which means, for instance, sharing your preprints. It costs nothing. You can use, for instance, SARC archive, which is the preprint repository of APA. And then we can also like self-archive our papers on our own website or on some non-commercial services. And I'm very big enthusiast of preprints. So each time before I submit a paper, I just submit the preprint to PsycArchive. I can already put it to my CV. I can share it. And this version of the paper, no matter where the paper will be published in the end, will remain freely available. And if you are using, for instance, Google Scholar, then you can notice that that there is somewhere a freely available version or copy of this peer-reviewed paper, which is published here and there in this or that journal. And then the other point is open peer review. Several journals introduce it, that like they wish to make the peer review more transparent. So they, for instance, publish the entire discussion between the authors and the reviewers. You can find it, for instance, in eLife, in several papers published in PeerJ, or for instance, in Royal Society Open Science. This is the routine way, and even the reviewer needs to like agree that like writing a review means that this review will be published. And it of course like increases the accountability of the reviewers as well. Like they can remain anonymous, but you are maybe like more motivated to be let's say like first of all honest, professional, and also polite to the authors, which I think helps to everyone involved. And then another thing, our, I guess, recent and great discovery about copyrights of figures. So this is the struggle we had several times, that we made a figure ourselves, we published it in the journal, which is not open access. And then we want to use this in a review paper, in the book chapter or so. And formally, we need to ask the publisher's permission when we want to put our own figure somewhere else, because otherwise it would be violation of copyright. So what can we do? Like the easiest way of doing that is to post the figures before we publish the paper, to post the figures on some repository such as OSF, Open Science Framework, to assign a DOI and a CC BY license to this figure. And then we simply cite it in the published paper. So we just cited like figure created by Krzysztof Cipora and available on Creative Commons license here and there. So then the publisher is just citing our figure. It's not, the publisher is not getting the copyright to it. The license of CC, the CC license allows like copying or reproducing the material, but the copyright retains with us, so we can then easily put it to our slides, lectures, book chapters, anywhere we like. And here, like in the slides, you can find the link to the paper explaining this procedure step by step. And then very important thing for open science is actually replicability. Mojtaba mentioned it in the beginning as a sort of problem. So here we can think of like 5 stages or 5 levels of replicability. First of all is the reproducibility of methods. So whether someone seeing our paper can reproduce the method, can reproduce the experiment. And of course, like the more we share, the more we make available, it makes it easier. And of course, it's very crucial also for like the replicability of the entire study and checking for robustness of conclusions. Analytic reproducibility is like refers not to methods, but already to results. So if someone has my data set and, for instance, gets all the materials that I made available, either just the description in the results section or the analysis code and so on, whether this person can reproduce my results in a sense that the things that I'm putting into the results section, whether he or she can obtain from analyzing my data in a way that I analyzed it or I reported that I analyzed it myself. The next step of reproducibility, of replicability, is so-called analytic robustness. So for instance, if someone has my data, knows my research question, whether this person can just select any statistical method, so to say, that he or she believes to be appropriate to tackle this question, and whether the conclusion will converge. Of course, there will be some like differences in whatever decimals or so, but whether my main conclusion still holds if someone analyzed the data in the way that he or she considers as suitable there. And then we have replicability, like whether if someone checks or whether if someone runs the same experiment as I did, whether he or she can replicate my effects, whether the effects are the same. So it's more about whether this experiment, so to say, really works in a way that the authors propose. And then generalizability is more about checking whether the theoretical, like answer to a theoretical question, the same answer to the theoretical question can be obtained if another type of operationalization is used. Okay, so we have like several, let's say, steps of ensuring replicability and also like making the psychological science more robust. And then why bother, right? Because it's like a hassle, it's like more work to document your materials, to document your data, and so on. So first of all, like open science is getting supported by several funding institutions. So more and more institutions are actually obliging the authors to deposit the data and made them available, like all the data that were collected within publicly funded projects. One of such initiatives within EU, like not all the countries are involved, it's called Plan S, and this puts an obligation to publish only in open access journals, that you cannot publish it anywhere else if you were funded from the public money. More and more often, like adhering to the open science practices is considered as a criterion for hiring, like for permanent positions. Here you can find the repository of all the or of several job advertisements which mention explicitly that this would be like one of the criteria. It's also getting encouraged by several prestigious journals, so they more and more often require sharing materials, data analysis, code, because they also like notice that this will improve the robustness and the trustability of the things they are publishing. And of course, you can also build your own reputation as an honest and transparent researcher who just publishes solid things. And this is in particular important for early career researchers, because if you are like making your work more open and transparent, you have also like more things to share, so to say. Like you can share your protocol, you can share your data, you can share your code, and then like someone who is like hiring you, even if you still don't have the published paper, but you have a preprint, you have all the materials, you have all the code, and someone is considering hiring you, then it's like more obvious what you can actually do, right? Because you just present your outputs. There are also some citation benefits and so on that I will just move on. So this is quite recent investigation of like how often about the citation advantage of papers which are published in the open access manner. So these are papers on the left, the gray ones, which are not openly available, and then bronze open access is something that sometimes journals just post for this or that reason, a paper which is like freely accessible. Sometimes it's like an sample articles or something like this. Then hybrid is when you publish in a journal that publishes both open access and non-open access. The open access requires like extra payment. Then gold open access are journals which are publishing only open access. Sometimes it requires article processing fee, like whatever PeerJ or PLOS. Sometimes it's free, like Journal of Numerical Cognition. And then we have a green open access. So this is the self-archiving by the authors and and preprints and so on. And all these which are like openly available get this citation advantage according to the study published in PeerJ some time ago. And also, very new paper published in PLOS suggests that also sharing the data gives you some citation advantage. They mention several reasons why it is the case, but in general, they show that it's about 25% advantage in citations. And also benefits for trainees. It's also kind of nice from the older colleagues, from more experienced colleagues, just to share not only the outcome, but also the process. And here, very nice case that we recently found. Some of you might know Mark Brisberg. He is like big expert in methods. Now he is actually editor-in-chief for behavior research methods, and he published a paper about power calculations. So methodological paper. It was published in Journal of Cognition. But what Mark did apart from that was sharing a preprint or like accepted version of the manuscript when he deliberately left all the parts marked with the specific color that were changed during peer review from the first submission. So you see, okay, one of the biggest experts in statistics and so on, and is writing a paper on statistics, and it still requires so much work and changes, and it's not that like you are so whatever scared or afraid that you cannot produce something which is perfect, but while you read any published paper, it's like so whatever nice and stuff. And you see that it's just a matter of a process. And here you can see that this process was also quite long, I guess, and also it required some work. So it's also great from the perspective on the side of more experienced colleagues who actually share it. You can have a look at the entire Mark paper with this changes on ResearchGate version of this paper by Mark. So you can just follow the link that I put here. And then you can become like sort of open access, open science scout. So it's like not all the journals actually are using it, but several journals adapted this badges system that you have the open data, open materials, and pre-registration badge, which you can put on your paper if you follow this, and then it shows that that it really works for the authors, that they can get some like direct benefit of a badge. And when it was introduced in journals which allowed it, the number of articles which were adding which were sharing the data along with the paper increased quite a lot when they introduced the badges. And then like content-wise, I guess it's all. If you are interested in open science and learning a lot new things about it, I would recommend these events. One of them is upcoming conference of Society for Improvement of Psychological Science. I guess Alexa, who is here with us, or at least was before, is involved in one of the events there. So maybe we can ask her a bit later to give a like official invitation to this one. Other one is just a YouTube channel, Riot Science Club. Very amazing videos on open science, integrating it with teaching and so on. All available on YouTube, highly recommended. And then like one more open science conference, which is again a virtual event happening in July, also free to register if you want to get more into these topics. All these events are really great, and you can get the links from the PDF that we shared. And here's some resources, some reading lists about open science, and also the previous by last one, this practical guide for transparency in psychological science. This is amazing. Like, it's a supplementary material of a paper, which is actually sort of a book with all of the guidelines on how to share the data, how to share your materials, how to ensure that the materials you share are reproducible, that you avoid the typical problem encountered in computer science, but it works on my machine, why it doesn't work on your. There are several safety measures you can make to avoid such things, and you can find it all in the paper by Klein and colleagues and in the supplementary material. Here's some, let's say, open science luminaries on Twitter you could follow and maybe should follow to see what's going on. It's very, let's say, vivid discussion on open science happening on Twitter. And there are some podcasts which are discussing these issues, also very much recommended. Of course, it's just a subjective list and not definitely not exhaustive. And then thanks for your attention. And before we go to questions, we wanted also to give birthday wishes to our like former lab leader, Hadzenur, who is here, and it happened that his birthday is today, so we can maybe like respond to this one by our clasping reactions, if you wish. Yeah, thanks so much.
Thank you very much, Mojtaba and Krzysztof. And happy birthday, Hatzi. Super nice. Yeah, so if there's questions, just just put them in the chat. I would first hand the word to Alexa, maybe, because she was mentioned just right now about the CIPS meeting.
Yeah, hi. Thanks, Krzysztof, for the shout out. Great talk, you guys. I really enjoyed this. I'm going to attach our unconference Google Doc in the chat box if you guys want to check that out. You can join us on Monday at 10 a.m. Pacific time. And then we have like kind of a weird lunch break, but we're going to be talking about teaching and mentoring open science. And it's kind of a cool format because it's an unconference. I don't know if anyone's been to CIPS before, but it's much more interactive than like just a presentation. So hopefully it'll be fun.
Right. So, is there any questions from anyone? I'll give you a few seconds and start with one of mine. So you gave us a very comprehensive overview on what you can do if you want to go open science, and it seems like a lot. So how are, I don't know, beginning PhD students, or whoever wants to start doing open science, how should they start? Where should they start? Do they have to do everything at once, sort of?
Krzysztof, you want to take this, or shall I go?
Yeah, I can. Yeah. So basically, the cool thing is that you have like entire freedom on where to start, and doing something is way better than doing nothing. As like people in numerical cognition, we should know that difference between nothing and something is quite a lot. So you can start from things which are kind of like easy or kind of let's say, like not so problematic or not requiring maybe some like larger effort. For instance, if you programmed your task, it belongs to you, right? Nothing prevents you from just sharing it on OSF. If you like prepared some R code, you can always share it because it's like, yeah, you can do it. What is also very easy and what actually costs nothing is, in my view, sharing preprints. Because most of the journals accept it, they have absolutely no problem with that. You can get some recognition already. You have something to put into your CV. You can advertise it over Twitter. You can get some reads. You can get some citations already, which count as your citations. You can also get some feedback. So, yeah, like feel free to start from anywhere you find it kind of doable at the beginning, and then it just progresses.
Exactly. To add a small point to that, if you haven't started your study, so the best start is to have a pre-registration, or if you have time, go for a registered report, and then the other things come along with that. The other point is you don't need to do everything at the same time. If you start with that circle, that cycle takes minimum of a year, so you have plenty of time to arrange the things step by step. But if you have already started your work, you collected the things, as Krzysztof said, you can jump just in the middle of that cycle, you know, and start sharing your material, and then later share your data. If you don't have ethical approval for that, then you cannot share your data, but then share your preprint because it's still yours.
Yeah, preprint is yours. You can still share your code, and there is something which is very cool called synthetic data set, which is kind of mathematical transformation of the original one. So there is no privacy issues because like the data just mimics the mathematical properties of the data set, but you don't have the same observations as originally. And then anyone can just like run your script on this synthetic data set, and then you can also show this form of transparency. There is one paper by Daniel Quintana published in eLife about this synthetic data sets. I can paste the link in a moment.
Right, so is there any comments, questions around? Not, I've got another one. Yes. So Andy, you've got a question.
Yeah, so I just have a question about kind of open science and secondary data analysis. A lot of what I do is using large scale secondary data analysis, prospective longitudinal studies, where a lot of the relations between various variables has already been examined in various ways, and oftentimes very kind of examined to death. Is there a way to go about doing, or what kinds of open science practices would you consider for using something like the ECLSK or one of the other kind of nationally representative data sets for whatever country you might be in?
Basically, there are some guidelines and preprints about, or even papers already about secondary data analysis, which apply specifically to this topic.
Yeah, basically you can pre-register that. There are journals accepting that. There are some special issues. They explicitly spell it out. You know, they mention that as a part of the list of the way that they accept the papers. If you are talking about one single data, this is the way. If you are talking about meta-analysis, which might be a part of systematic review or standalone, there are websites like Prospero that you can do. This is a kind of, it's called protocol, which is which works similar to pre-registration. Basically, you are sorting all the things that you are planning to do there, and you get stamp on that, and then you can get through. Yeah.
Yeah, I just put on the chat the link to a preprint about this guidelines for registering secondary data analysis, if anyone is.
Awesome. Thank you so much, both of you.
All right. So we're really perfect in timing. I still have like one more question though. So what do you think changed with your workflow from, you know, before to after doing open science? Any insights?
Very good question. It's a very good question. So in my case, I got way more relaxed in doing science, and I will tell you why. Because with open science, with like particularly register report, when you register your idea, your things there, so you get already a sort of guarantee for publication. So you don't carry all the stress of what you will find, how to reanalyze in hundreds of different sort of analysis that we used to do. to get something out of it, and then speculation and several meetings, how to justify why we did that, and then writing that down, and then you get conflict with the reviewers. You get rid of all this stress along the way that you do. And in my view, then you can do way better science.
Yeah, and if I can add something, the pre-registration, also even filling in this as predicted form actually solved so much problems at the beginning that we thought that the design for the experiment was like ridiculous in a sense. It was so simple, like everything is clear and so on. But when we really wanted to frame it in answers to these 9 questions, we spent like full day on this one. But now at least we know how we actually want to analyze this data, and of course it also helped us to somehow like specify or correct the design or adjust the design so that like all these corrections were way easier to implement before we actually invited our first participant to the lab, because then you can change everything and then you don't need to find any sort of complicated post hoc explanation or stuff like that.
All right. Great, so I don't see any more questions. I hope I didn't miss some. So then I would say thank you to everyone. I think we'll stick around a couple of minutes. So if something comes to mind, please say hello. If not, I would hope to see every one of you next week for the launching event. Yeah, and thanks to everyone. Thanks to you, Mojtaba and Krzysztof, and everyone who attended.
Sure, thank you very much, everyone, for being here and listening to us. Yeah, hope to see more open science in our field. Have a good day.